Topic: momentum. Momentum. Okay. Momentum. Is the spelling correct? Yes, it is. Now, what did we say momentum was? We said that momentum is quantity of motion. Quantity of motion. Another definition was mass in motion. I'm going to explain shortly. So how did we get to that definition? I used an example. This is just like a 6-minute summary of what we covered last week. So I used an example to justify this definition. I said if you have a small motor car like that, it's like a small car, and then a massive truck, let's just say a bus. Okay, the bus is of let's just say 1,000 kgs. Just an example. It's not realistic. And then the motor car is 2 kg. Right? They are moving in the same direction to the right, both at the velocity of 4 meters per second. Ne? They are moving at the same speed, which means that they're literally moving on the same like line like this. They're level. They move on the same line like that. They're level like that. Okay? Sharp. Now, as they move, let's just say they move from that side, from the right, from the left, they go into the right like this. They're moving, they're moving, they're moving, they're moving. And then as they get to this point, this very point here, let's call it point A, né? They get to this like point here. I apply brakes, or we apply brakes on both of these objects at the same time. So we're basically trying to stop both of them. So apply brakes of 10 newtons. I got it. Braking is like a form of frictional force. It stops the car. It resists motion. So apply a brake of 10 newtons or minus 10 newtons on each of these two objects at the same time, right? At point A, literally point A. Ne? Which one is going to stop first? Which one is going to reach a stop first? Don't be shy. It's okay to get a question wrong. Or which one is going to stop further? Remember that they're moving at the same velocity of 4 meters per second, and then at a certain point A, at the same sort of line, we apply brakes of 10 newtons. 10 newtons just means that like we're stopping the object, so one, and then we know that braking is just a frictional force, so we just call it minus 10 newtons, just a hypothetical number. And then yeah, so my question is, which one is going to stop further? Use logic. You don't have to use calculations. Which one is going to stop later than the other? Yes, 1,000 kgs. Yes, the bus will stop later than the motor car because the bus is heavier, right? So if you apply the same amount of braking, the bus will stop further. So you might find the motor car will stop maybe somewhere here, while the bus will stop somewhere there. Why? Because the bus has more. It's heavier. It's got more mass. It's 1,000 kg, while the motor car is 2 kgs. So the reason that is the case is that the mass. Are we happy? Does it make logical sense to each one of you that the bus stops at a further like point? Hmm. Proper stuff. So now this is due to the mass, despite the fact that they are moving at the same velocity, right? So now a scientific way of describing that sort of phenomenon is, or rather, the scientific word is momentum, right? Mass in motion. Like both of them are moving at the same speed, but the bus has more quantity in motion. It's got more motion, even though they're moving at the same speed. It's got more richness in motion. I don't know how to put it. It's got more motion. Okay, even though they're moving at the same speed. Sharp. So now this is what we call momentum. Quantity of motion, mass, and motion. Now, do you guys clearly see what momentum depends on the weight of an object? Do you guys see the mass of the object? Ne? Now, if I had like a 2 kg object there moving at that velocity and another 2 kg object moving at the same velocity, I apply the same amount of braking of minus 10 newtons, they'll stop at the same point because they have the same mass and the same velocity. Let us look at a slightly different scenario quickly. This is just a summary of what we covered last week. Like I said, 6-minute summary to get your blood flowing and get you to remember what we did last week. Very important. Got what do you call it? I've got two identical motor cars. Okay, this one is of mass 2 kgs as well. This is moving at 4 meters per second, while this is moving at 6 meters per second. They're moving at the same. Sorry, they're not moving at the same thingy velocity. Now, let's just say they are moving, but both of them are at this point, right? Obviously, this one is moving faster. If I apply a braking force of 10 newtons on each one of them, 10 newtons at the same point, 10 newtons, which one is going to stop at a further point or later? Which one is going to stop at a later point? Waiting for you to try and get it wrong or get it right. Whichever one's still fine with me. Yes. The one with the high velocity, the second one, it's gonna stop further. Why? Because yes, the weight of them is the same. Yes, they've got the same weight or the same mass, but this one is moving faster. So it's gonna take. It's gonna this one. If you apply the braking force of minus 10 newtons, this one is gonna probably stop here. This one there. Why? Because it is moving at a higher velocity. It's got more quantity in its movement, in its motion. It's got more mass in its motion. It's got more quantity in its movement. Do you guys see that? This is what we call momentum. We say this one has more momentum than that one. Okay, even in this first instant, we say this one has got more momentum than this one because it takes much more time for it to stop, even though we apply the same amount of braking force. Do you guys understand momentum, like in simple terms, without using physics, but like in common sense? Do you guys understand? Please ask questions if you don't understand what momentum.